Steel truss systems are engineered structures used to support multiple pipelines transferring petrochemicals from shore facilities to jetties or wharves where ships are loaded. These trusses act as elevated bridges, spanning over water or land to ensure safe and efficient transport of hazardous liquids. Steel trusses, with their high strength-to-weight ratio and adaptability, are indispensable in supporting pipelines, utilities, and equipment across refineries, terminals, and offshore platforms. These structures must endure harsh environmental conditions, dynamic loads, and stringent safety requirements. Several truss configurations are commonly employed, each tailored to specific operational demands. In steel truss systems, the connections between members are critical for transferring loads, ensuring structural integrity, and accommodating movement for thermal expansion or dynamic forces. The type of connection depends on the truss design, material, load requirements, and industry standards. The most common type of connection methods used in steel truss systems are bolted connection and welded connection. Bolted connection are among the most widely used methods in steel truss systems. These joints employ high-strength bolts, nuts, and washers to fasten members, often supplemented by gusset plates, flat steel components that distribute loads across multiple truss elements. Bolted joints are categorized into bearing-type connections, which rely on the shear strength of the bolt shank, and friction-type connections, where pre-tension bolts generate clamping force to resist slippage. The modularity of bolted systems allows for easy assembly, disassembly, and adjustments, making them ideal for temporary structures or projects requiring rapid deployment, such as offshore platforms. However, these connections demand meticulous design to prevent stress concentrations at bolt holes and require regular inspection to address potential loosening from vibrations. Welded connections, created by fusing steel members through arc welding techniques, offer unparalleled rigidity and load-bearing capacity. Fillet welds, which form triangular joints along the edges of members, are common for non-critical connections, while groove welds provide full penetration for high-stress applications. Welded joints eliminate the need for bolt holes, preserving the structural integrity of members, and are often used in custom geometries, such as space frames in LNG terminals. Despite their strength, welded connections are labor-intensive, require skilled craftsmanship, and are susceptible to thermal distortion. Post-weld inspections, including non-destructive testing and DT, are essential to detect flaws like cracks or porosity. The diagrams in this slide show various types of connection detail for shear connection and moment connection using bolts or welds. Similarly, we can also see various diagrams of connection for the bracing. Here is an example drawing of a typical steel truss system designed to carry petrochemical pipes. Most of the structural members are made of 152 by 152 by 36 kg per meter and 254 by 254 by 74 kg per meter steel sections. The span is more than 16 m. The load on the structure at various levels are as follows. Upper level equals 4 kN per meter. Middle level equals 6 kN per meter. Lower level equals 5 kN per meter. Notice how the truss are braced with different type of bracing configuration.